Okay, today we're going to look at the cross product, which is the second type of vector multiplication. Last class talked about the dot product, and when you take the dot product, the result is a scalar. But for the cross product, the result is a vector. So let's look at this example here. We have we've got u and v as two vectors. And if I was to calculate u cross v, the answer is a vector. Now, the question is, how do I actually draw this vector? And the one thing that is unique in this is we have to find, one property of the cross product is that the resulting vector is perpendicular to both u and v. So I'm going to give you a second and ask the supply teacher to pause the video for a moment and talk to your elbow partners about where a vector could be that is perpendicular to both u and v. So hopefully you've had a chance to think about this, and you may or may not have figured it out, but I'm going to talk you through it. So if we drew a vector that's perpendicular to u, there's a possible vector, but of course that one is not perpendicular to v. You could draw one over here. That one is perpendicular to u, but not to v. So now let's start looking at vector here. That one's perpendicular to v, but not to u. So none of these seem to be working. The only way you can find a vector that is perpendicular to both of them is to actually go into 3 dimensions. And a vector that's going to be perpendicular to both u and v is actually going to come out of the screen at you. Now, I can't demonstrate that through this video, but I'm going to show you another video in a moment that demonstrates a vector that is going to come either out of the screen or actually into the screen. So instead, I'm going to try and take this picture and try and draw a 3-dimensional one. So pretend that this is now in 3 dimensions and these two vectors are lying on a piece of paper. And I'm going to draw a third vector that is perpendicular to both of those. Sorry, just cancel that. And maybe you can visualize this. We've got a vector that's perpendicular like that, and a vector that's perpendicular like this. So this one is, that should be coming straight out of the page. There you go. This one is u cross v, and it is perpendicular to both u and v. So now, if you can imagine that as a 3-dimensional picture, imagine the u and v vector lying on a piece of paper on the desk, and there is u cross v coming straight out of the desk. So our answer is either straight out of or into the page. And to figure that out, I'll refer to something in a moment. But back to u cross v. Not only since it's a vector, it's not only going to have a direction, but it's also going to have a magnitude. So the direction is all the stuff over here that you'll figure out that it's some vector either out of the page or into the page. But the magnitude is found just by doing some calculations. Now you remember that u dot v was the magnitude of u times the magnitude of v cos theta. Well, it turns out the cross product is the magnitude of u times the magnitude of v sine theta. So dot product is cos theta, cross product is sine theta. We'll have to practice remembering each one of these. Now, since that's how big the vector is, but it also has to have a direction on it. So we're going to say that we're going to add this little thing at the end here, which is called, it's a vector that's perpendicular to both of them. And it's called the normal. Now, don't worry about the little notation. It's a little hat above it. It's actually called a unit vector. We'll talk about that later. Right now, you just need to know that it's a vector, different symbol, and it's called the normal. Now, you might have come across this before in your book. The normal is a vector that's perpendicular to both of these. I'll straighten that up when I get a chance to see you in person. All you need to know about right now are two things. To find the magnitude of u cross v, you take the magnitude of u times the magnitude of v sine theta. And then you have to figure out if the picture is coming straight out of the page or into the page. And to do that, you need something called the right hand rule. And to explain the right hand rule, I have another video that you can watch to see how to figure out whether the vector comes out of the page or into the page.